JEE Advanced 2025, Paper 1 Physics, Question 15. Let us visualize the 4 AC circuit configurations in this matching problem. The source voltage is V of t equals 300 sine of 400 t volts, so the peak voltage is 300 volts and the angular frequency omega is 400 radians per second. Configuration P has a 30 ohm resistor only. Configuration Q has a 30 ohm resistor in series with a 100 millihenry inductor. Configuration R has a 50 microfarad capacitor, 30 ohm resistor and 25 millihenry inductor all in series. Configuration S has a 50 microfarad capacitor, 60 ohm resistor and 125 millihenry inductor in series. Here is the complete question. An AC circuit has an impedance Z. The voltage is V of t equals 300 sine 400 t volts. Match list 1 containing load configurations P, Q, R, and S with list 2 containing current waveforms 1 through 5. The waveforms differ in amplitude and phase shift. We must find the correct matching. The key concepts for AC circuits. The impedance Z of a series RLC circuit is given by Z equals the square root of R squared plus XL minus XC whole squared. Here, the inductive reactance XL equals omega times L, and the capacitive reactance XC equals 1 over omega C. The peak current I0 equals V0 over Z. The phase angle phi is given by tan phi equals XL minus XC over R. If XL is greater than XC, current lags the voltage. If XC is greater than XL, current leads the voltage. At resonance, XL equals XC, so Z equals R and the current is in phase with voltage. Now the solution. We have V0 equals 300 volts and omega equals 400 radians per second. For configuration P, R equals 30 ohms, resistor only. Impedance Z equals R equals 30 ohms. Peak current I0 equals 300 over 30 equals 10 amperes. Current is in phase with voltage. This gives amplitude 10A and 0 phase shift, which matches waveform 3. For configuration Q, R equals 30 ohms and L equals 100 millihenry. Inductive reactance XL equals omega L equals 400 times 0.1, that is 40 ohms. Impedance Z equals square root of 30 squared plus 40 squared, which is square root of 900 plus 1600 equals 50 ohms. Peak current I0 equals 300 over 50 equals 6 amperes. Phase angle, tan phi equals 40 over 30, giving phi approximately 53 degrees. Current lags the voltage. This matches waveform 5. For configuration R, C equals 50 microfarad, R equals 30 ohms, and L equals 25 millihenry. Capacitive reactance XC equals 1 over omega C, that is 1 over 400 times 50 times 10 to the minus 6, which gives 50 ohms. Inductive reactance XL equals 400 times 0.025 equals 10 ohms. Net reactance X equals XL minus X, C equals 10 minus 50 equals minus 40 ohms. Impedance Z equals square root of 30 squared plus 40 squared equals 50 ohms. Peak current I0 equals 300 over 50 equals 6 amperes. Since X is negative, meaning XC dominates, the current leads the voltage. This matches waveform 2. For configuration S, C equals 50 microfarad, R equals 60 ohms, and L equals 125 millihenry. XL equals 400 times 0.125 equals 50 ohms. XC equals 50 ohms, same as before. XL equals XC, so this is resonance. The net reactance is 0. Impedance Z equals R equals 60 ohms. Peak current I0 equals 300 over 60 equals 5 amperes. At resonance, the current is in phase with the voltage. This matches waveform 1. The correct answer is option A. P matches waveform 3 with 10 amperes in phase. Q matches waveform 5 with 6 amperes lagging. R matches waveform 2 with 6 amperes leading. S matches waveform 1 with 5 amperes at resonance. Here are important exam tips. Tip 1. In matching problems, first compute impedance Z and peak current I0 for each configuration. The amplitude alone can eliminate several options. Tip 2. Always check for resonance. When XL equals XC, the impedance is purely resistive and current is in phase. Tip 3. Remember the phase convention. Inductive circuits have lagging current, capacitive circuits have leading current. Tip 4. For quick impedance calculation, recognize the 3-4-5 Pythagorean triple. If R is 30 and net reactance is 40, Z is 50. This saves precious time. Like and subscribe for more JEE Advanced solutions at MAGPIEHUB. See you in the next video.